know that I'm recording the lecture. Hang on again while I admit people from the lobby. All right, so I'm recording the lecture. All the lectures will be recorded and posted probably, well, I'll try to do it the day of I give the lecture, but sometimes it'll be a day or two before the lecture recording gets posted. You can always get to the lecture recording if you go to the meeting link on Teams. It will be there in the conversation somewhere. You'll be able to see a link to the lecture recording. Otherwise, they will appear on the course OnCue, and the videos will normally be hosted on YouTube instead of whatever Queen's uses, because a lot of students who are overseas have trouble with the Queen's link. All right, so let's get on with this lecture. So who am I? I'm Dr. Burton Ma. I am a Queen's alumnus, actually, undergrad and graduate student from many years ago now. I was at York University, but then moved here a couple of years ago. Obviously, my office is not relevant at this point in time, but if I ever get back to in-person office hours, I'm in Goodwin 754. Office hours for the course will be on Teams, probably even after we come back in person after February. Meeting hours are to be announced, but the hours will be posted on Teams, as well as a link to the virtual office hours. Oh, hang on, sorry, that's wrong. I teach a bunch of courses, so I wonder if this is the right, well, let's see, let's hope, see what happens. I teach a bunch of courses, so if you contact me by email, it would really help if you put CISC 124 in the subject line so I know what course you're in. I get a lot of emails that say something like something, something, something assignment 1 or something, something, something assignment 2, and I have no idea which course you're in. And it's a real, it's actually not convenient at all to try to figure out which course you're in. It's not easy to do. So if you contact me by email, please put the course code in the subject line. That's my email address. Teaching assistants, we do have several for the course. They will have office hours as well. Once we have the teaching assistants settled and their office hours set, that information will appear on OnCue as well. Course information, everything's on OnCue, or will be on OnCue. Lectures obviously are virtual, so they will be live during the regularly scheduled lecture time, and of course they're recorded. If we come back in person after February, depending on the lecture hall that we're in, the lecture hall may have live streaming capabilities, and so to get to the lecture, to get to those lectures, if you want to watch the live stream, you'll have to go to a web link, which I will make available to you if we ever get back to in person. But again, they'll still be recorded, so you'll still have access to them, even if you can't make the regular lecture time. Textbooks. So this link is old. It's gonna, well, not old. It's 1 term old. This is the link from last term. There'll be a new link. It'll be winter 2022. So there are the course notes are provided as Jupyter notebooks. So there's essentially a textbook that's been written for the course. They appear in the form of these notebooks, these electronic documents. I'm going to demo these at the end of the lecture, so I'll show you how to use them. You can, if you want to have your own copy of the notebooks, there is a way to install the necessary software on your computer so that you can view and edit the notebooks. If you're not interested in having your own copy, there is, you can always use this link here, or the updated one when I post it to OnCue. So there's an online version of the notebooks as well. I'll explain the advantages and disadvantages between the personal version of the notebooks and the online version later on. There's no textbook that you have to purchase for the course, but if you do want extra reference material, the library has many excellent online books. One of them is this book here, Introduction to Programming in Java, an interdisciplinary approach. This textbook in particular has a really great collection of exercises, especially if you're in the sciences or engineering. It's weak in some aspects of object-oriented programming. So in particular, the entire third part of this course is lacking. Third part of this course is lacking in that textbook. If you are serious about programming and you think you might pursue a career in Java, where you might have to program in Java. Sorry, whenever I'm looking away, I'm doing something in Teams. You should, at some point, read this book. It's called Effective Java. It's written by one of the people who designed and implemented the Java programming language. It's more or less considered must reading for any professional programmer. The library has, well, what just happened there? That was fascinating. The library has, last time I checked, the link in the library was for the second edition, but we actually have access to the third edition, which is the most recent edition. You can actually find it if you poke around when you get to the publisher website after you follow that link there. Labs. So there are labs associated with this course. They are virtual, even after reading week. So I know you had to pick a lab time for this course and schedule it, and hopefully you didn't go through too much trouble trying to work around the scheduling. They're virtual, so there's you can complete them anytime before the due date, if there is one for the lab. There's not going to be a due date. There may not be a due date for every lab. Any lab exercise that's you have to submit is very small, is relatively small compared to your assignments. So your scheduled lab times are, for the time being, they're unused. So your labs are going to appear as video recordings. So there'll be a set of video instructions. Mostly the labs, especially the early ones, so the first 4 or 5, maybe even 6, they're going to show you how to use the development environment, the development tools that we use in this course. So the first lab, for example, will show you how to install Eclipse and a JDK so that you can actually do some programming in Java. So for the time being, the scheduled lab times will not be staffed by me or a TA, but that might change if students are having trouble with completing the labs. So we may end up scheduling office hours during lab times to help students who are trying to do the labs in their scheduled lab time. The problem with the scheduled labs is that there's quite a few of them, which means either me or a TA has to dedicate many hours a week just sitting in a lab, usually not doing much of anything. Okay, grading. So this is going to be, I haven't set the official grading scheme yet. It'll be posted later on OnCue this week. There will be assignments roughly every 2 weeks, so there'll be either 5 or 6. There are weekly labs. If they contribute to your grade, then their contribution is very small. So like on the order of 1% a lab. There will be a midterm quiz or possibly quizzes. I haven't decided yet. They will be on OnCue, and there will be an exam in the course. Your assignments, they're supposed to be done individually, and you submit them on OnCue. Solutions are posted 3 days after the assignment is due, or at least that's the plan. It doesn't always work out that way. The reason it doesn't work out that way is because a lot of students end up trying to submit late for some reason or the other. Especially last term where people catching COVID was a real problem. So the late submission policy for the course is that nothing's accepted after 72 hours after the posted due date. And that includes students with accommodations. So if you have an accommodation that requires like a week extension, you have to contact me for alternate arrangements. The reason this policy is here is because I really want to get the assignment solutions out to you shortly after the assignment is due. so that you can see how I, for example, would do the would complete the assignment. There's a 10% penalty per day that you're late. So you lose 10% of the total marks for every day that's late. So if the assignment's out of 100, then the most you can get after being late, 24 hours or less being late is 90, and then 80, and then 70. Quizzes, formats. Well, I mean, the quizzes are going to be online and on OnCue. They'll be scheduled during a lecture when we have them. So I will post the dates sometime this week. The exam format is to be determined. I would prefer if they're in person because it's about 10 times faster to mark a paper exam than it is to mark an exam on OnCue. But depending on how the pandemic works out, they may be online on OnCue. Okay. Anybody have any questions about course administration so far? You need to put your hand up or unmute or whatever you want to do to ask. Alrighty. So what's this course about? So this is basically an introduction to object-oriented programming. I'm going to explain what that is in just a minute. You can see that the calendar description says we do a bunch of stuff, and it's true, we do a bunch of stuff. Basically, the goal in this course is to teach you about object-oriented programming and software design using Java. I guess software design, and, well, more software development than software design. This course is more interested in the development rather than the design aspect. Okay, so the programming language is Java. Where is this? Do I tell you? I'm just gonna, okay, so I'm gonna talk about that later. All right. Okay, so what is object-oriented programming? So this is one of the more widely used programming paradigms. So a programming paradigm is a way of, well, it's a methodology of programming. What you learned in CISC 121 can be called structured programming. So basically in structured programming, your program is controlled by loops, if statements or conditionals, and function calls. The way you were taught CISC 121, you probably, so your program has information, right? So it's got data of some sort. The way you were taught CISC 121, your data probably lived either as global variables or they lived as variables somewhere in a function somewhere, right? Normally, probably a main function of some kind, right? The function where your program starts running from. And then you pass around that information to other functions, right? If they're global variables, then the functions can access the information via the global variables. In object-oriented programming, the structure of your program is different. So you have a program that's made up of things called objects, right? That's why it's called object-oriented programming. The individual objects, they have what's called state. So every individual object has data or information. And the object can act on that information, right? So it can manipulate that information, it can read it, and it can modify it, right? And the way it reads and the way it accesses the information, or the way that the programmer controls the object, is through these things called methods, which are more or less functions, right? It's what you know as a function. Because your program is made up of one or more objects, objects can interact with one another by passing messages. Right? So that's the object-oriented terminology for it. But all that means is that if you have two objects, the objects are allowed to call methods on one another. Right? And so what you have is a bunch of communicating objects that make up your program. So any information that your program needs to manage, they live in objects. Right? Now there's lots and lots of other different types of programming paradigms. So these aren't the only two. And you'll learn about other programming paradigms if you continue to take more courses in computing science. So in particular, there's a second or third year course that is strictly about different programming paradigms. So in that course, normally you look at 4 or 5 other programming languages, all of which do things in very different ways. Our focus in this course is object-oriented programming. All right, so our programming language is Java. Now, what's Java? So Java is what's called a general purpose language. So that means it's a language that can be used for many different applications. Right? So it's not focused on one particular type of application. It's cross-platform, which means it can run on many different types of computers. Right? So it can run on a tablet, a phone, or a desktop computer. And it's an object-oriented programming language. It was created in the early 1990s, so it's about 30 years old now. And when it was created to address the issues with the dominant programming languages at the time, which at the time were C and C++ and a few others. When it was created, the internet was still very new. So Java is very much a network, is very much a language associated with networks. The goals when it was designed are these 5, right? So it's supposed to be simple, well, relatively simple. Now, by simple, simple and robust and secure, these two are related. So the way that C and C++ worked at the time in the early 90s is that the programmer had to manage memory themselves. And managing memory is a little bit tricky to do. You'll learn more about this if you take CISC 220, the systems programming course where you learn C. So memory management is, in principle, it's easy to do, but in practice, it's hard to do. And so Java takes away most of the memory management, most of the manual memory management that you had to do in C and C++. Right, so that simplifies a lot of things, and it makes your programs, it helps to make your programs more secure. It was meant to be architecture neutral. So when you program in C, you can write a program once, but you have to compile it separately for every type of computer that you want to run it on. So if you write a C program for a if you write a C program, you want it to run on Windows and Mac, you have to compile it for both Windows and Mac. At the time when the Java was created, there were several different operating systems and several different computing architectures available. If you're programming in C, you have to compile for every one of those. Java was meant to write once and then run anywhere. So it was meant to be architecture neutral and portable. So that's what that means. Java today runs quite fast. So a modern Java virtual machine and a modern Java compiler produces code that's pretty fast. It's not as fast as pure C or Fortran if you're doing scientific programming, but it's quite fast. When it first came out, that wasn't necessarily the case always. And then 5, it was designed to be interpreted, threaded, and dynamic. So those are all terms that you'll learn about as you progress through your computing science undergraduate degree. Okay, so where's it used? A lot of enterprise software is written in Java. Probably most enterprise software. Well, a lot of it's written in Java. Enterprise software is software that's used by very, very, very large organizations. On the server side, so as I mentioned already, Java is very common in the network world. So anything server or big data related, so these are things that companies like Google or Netflix, who else? I guess Meta or Facebook. Any of these big companies, any of these companies that have very, very, very large, that have to deal with a lot of network or information. A lot of their software is written in Java. Not all of it, of course, but a lot of it is. Java can run on embedded devices, in particular Android phones. Things like clocks or small devices that don't have a display, those tend to be programmed in C. It's used in some scientific applications. So NASA in particular has a lot of software written in Java. And then there are some video games that are written in Java, although any high performance video game is probably written in C++. I guess the one notable video game that most of you will have heard of was the original Minecraft. It was written in Java, although now a lot of it has been rewritten in C++ because it was bought by Microsoft. I guess the other video game that you might have heard of, the other contemporary video game that you might have heard of is Slay the Spire, which is also all pure Java. If you have time and you're interested in this sort of thing, you can hit that link and find out more about where Java is used. This is a blog post. Oracle is the company that's now responsible for the Java development and maintenance. They have a blog, and whoever the blog author is wrote an article about what they thought the 25 greatest Java apps ever written are. There's some very interesting applications that have been written in Java. Okay, now why not Python? So in CISC 121, you learned, and CISC 101 if you took it, you spent a lot of time learning Python. So why don't you just continue using Python? Because Python also has object-oriented capabilities. The reasons are, it's good for you to learn different programming languages. In fact, there are some professional programmers who say you ought to be learning a new programming language all the time. So you'll find books like Learn 7 Languages in 7 Weeks and things like that. It's good to learn different programming languages to see how different languages work and how they approach the same problem. Now, if Java is also easier to so if you learn Java, it's easier to transition from Java to C and C++ than it is to transition from Python to C and C++. This is important because a lot of your upper year CISC courses are taught or use C and or C++. So for example, CISC 220 is the course that teaches you how to program in C. And then there are several other courses that follow on that require whose assignments or coursework are done in C and C++. So it's much easier to transition from Java to C and C++ than it is to go from Python to C and C++. Okay, now, because this course is in Java, you need to somehow get a Java development environment installed on your home computer. So you're going to need a Windows PC or a Mac PC. It doesn't matter which one you use. You're going to have to eventually install what's called a Java Development Kit, or JDK. This is going to be the topic of Lab 1, so there will be videos that take you through the entire process for both Windows and Mac. Let's see, so Oracle has committed to 6-month updates of Java. So every 6 months, a new version of Java shows up, which is really annoying for teaching this course anyway. The current version of Java is Java 17. Now, when Java updates, so every new version, they really don't add a lot to the language. Usually the additions are very small. So the reason Java 17 is recommended is because it's the most recent version, and Oracle makes it a slight pain in the butt to install an older version. So you have to, if you want an older version of Java, you have to sign up for an account, and then you have to hunt down the web page that has the old versions of Java. If you want, you can use what's called the OpenJDK instead, but installing OpenJDK is harder than installing the Oracle version of Java. You need a development environment. So after you install the JDK, you need something that will let you program in Java. So the recommended IDE for this course, so it's called an integrated development environment, is Eclipse. It's free. It's open source. There are lots of other IDEs available. So IntelliJ is probably the other big one that you might consider. But I can't support all of them. So I'm only supporting Eclipse in this course. All of the course materials are distributed in Eclipse. You can use a different IDE if you want to, but you'll have to figure out how to use it on your own. Visual Studio Code is another. It's not really an IDE. It's basically a text editor, and you can install some development tools on it. So you can use that as well, but again, you'll have to figure out how to use it on your own if you don't want to install Eclipse. All right. What else we got? Okay, finally, the notebooks. So the all the course content for this, not all of the content, all of the learning content, right, is available to you in the form of what's called a Jupyter notebook. Installation instructions will be posted on OnCue. They're not there right now because I have to make sure that they're up to date for this term. There's two ways to use the notebooks. So one way is you install all the software that you need to run the notebooks. It's a fair amount of software that you have to do, that you have to install. Installation is not exactly trivial because it's all open source stuff. So there aren't any really nice installation. There's no like one program that you can download and install everything for you. It doesn't work that way. The other way to use the notebooks is via the internet. So I'm going to show you all this in a second. If you decide to try to install the notebooks on your own computer, there's a few things you need to know about. The notebooks are written using an older version of the software. The updated version of the software, something's broken. So the Python code cells are not working. So I'm going to show you what that means in a second. The other problem is if you got your computer set to some non-English character set. So for example, if you're using one of the Asian character sets on your computer, then the notebooks probably aren't going to run the code cells. You can still read them. You just can't use them the way you're supposed to be able to use them, which is why the online version is also made available to you. All right, so I'm going to show you what these notebooks are right now. Dead kernel. Okay, so the Jupyter notebooks, they just run in a web browser. This is the online version of the notebook. So before class started, I loaded the online version of the notebook. The online version of the notebook runs on someone else's server. And so if you don't do anything in the notebook, so if you open the notebook and you're idle for I think 10 or 15 minutes, then the server that the notebook is running on shuts down automatically, right? Because you're basically running this stuff on someone else's computer. And you don't have to pay for it, right? So if whoever's hosting the notebook sees that you're not using it for anything, it just shuts it down, and you end up with this message here, right? If you click the try restarting button, it never works. So what you need to do is you need to go back to the original web page, right? Which is hosted on this site called Binder. Oh, invalid build token. All right, so let me just try reloading this manually. So this is what you need to do when you follow the link. So what happens is this website looks for a running version of the notebook. So it looks to see if somebody already has this notebook up and running on a server somewhere. If it is, then you fairly quickly end up with a notebook that opens up. If it can't find a server that's running the notebook, it has to launch a server somewhere. And so that can take a few minutes. The notebooks look like it looks like a web app, right? So it looks like something like a Google document or something like that. The information is provided via a web page. Right, so if you click on one of these things, for example, that one, right, you'll see that the notes, they're basically written like an online textbook. Right? So you basically have a free textbook for the course. Now, the way you should be using the notebooks is not as a traditional paper notebook, right? So yes, you should read it, but if you scroll through the notebook, for example, you'll hit these cells that appear in gray. Any of these gray cells contain code of some kind in them. So this cell contains Python code in it. Whenever you see a cell, you can actually run. Whenever you see a code cell, you can run the code cell. Right. So for example, you press the run button. This one, hopefully it works. Yeah, this one doesn't work. Okay. So there's something going on with the most recent version, with the version of the Java kernel that's causing this to no longer work. So if you see a Python code cell, it may or may not work. However, if you see a Java code cell, which is what most of the textbook code cells are, they do work. So if you run this code cell, it will compile that Java program that's sitting right there. Right. So that program right here is the standard Hello World program written in Java. Right. So if you have a complete program, running the cell compiles the program that's in the cell. Right. And the output that appears here is this strange message here. Right. So this is just the message that says this program has been compiled, but it hasn't actually been run. To run the program, in this case, I have to manually call the main method that's sitting there. Right. So to run it, you have to have another code cell that actually runs the code cell. Right. So when you get a complete program, there's two cells that you have to run. Right. But you can run the cell. Now, this is a live document, so you can come into this cell and you can change it. Instead, I can change the message to something like this. I can run it again to recompile it, and then I can run the method again. And you can see the output now changes. Right? So the notebooks are meant to be used interactively. Right? A lot of the notebook examples, a code cell will appear. You run the code cell to see what happens. Right? You can go back and modify the code cell. So you can change the code cell to see what happens when you change the code that's in the cell. So let's look at a more interesting example. For example, so let's do some arithmetic. I forget to not load. Okay, so here we go. So in the arithmetic notebook, right, you can see that there are exercises in the notebook. Right. So embedded in the notebook are exercises, which you can now do. Right. So there's a code cell here where you can complete the exercise. Right. And this one asks you to evaluate the following expressions using Java. Right. So if I want to evaluate 1 plus 1, I can do something like, I want to print it out, I can do something like the following. And then I can run it right away. Right. And there you get 2, which is the answer you would expect. Right. So in the nice thing about the notebooks is you do not need a complete program to run the code. So if you were doing this in Eclipse or writing your own Java program to try to solve this exercise, you'd have to make a class, you'd have to make a main method. Inside the main method, you'd have to put these 2 lines of code. Right? Then you'd have to compile it, and then you'd have to run it. The Jupyter Notebook cells are able to take incomplete programs, right? So fragments of code, and then run the fragments of code, right? Which is really nice if you're a beginning programmer or if you're just learning the language, right? So you don't have to go through all the trouble of making a class and making a main method and then putting the code inside the main method, right? You can just plunk down whatever lines of code you're interested in learning about. So here I'm interested in learning about arithmetic. I can just write some arithmetic in the cell and run it right away, right? So to do the next one, I need something like the following, something like that, right? You can cut and paste in the application, right? So Control C, Control V, Control X, they all work. If you're on a Mac, Command V, Command C, Command V, and so on. Change that, you can run that, right? And there you go, and so on and so on and so on, right? So if you keep on reading this notebook, you'll see that there's some explanatory text. Then there's this huge cell here, right? That contains a bunch of code, and you can run that cell, right? And you can go back, right? See what this is trying to do. It's trying to compute. What's it trying to do? It's trying to compute 3 times math pi divided by 2, 180. Sorry, not 180. What's it trying to do? Pi over 2. 3 times pi. Sorry, 270 degrees. Oh, hey, there's a comment here. In radians, right? If you scroll down here, right, you can see the output here, right? And then again, you'll see an exercise, right? Now, the other thing you can do is that you can't. So you can. It's true you can edit a code cell, but you can edit or add your own text cells if you want to, right? So for example, if you're doing this exercise and you get stuck on something, and you want to make a note to yourself to, for example, ask the TA or professor about it during office hours, you can insert a new cell, right? So click on a cell, right? You see it's outlined in green, right? Insert below in this case, right? You'll get a code cell. If you want text, you want to change it to a markdown cell. And then here you can type in a note to yourself. So a note, ask prof about 1, 2, 3, 4, 5 about the 6th problem. And then you can run that, and you've now got a permanent note in your notebook. Okay, so this is the first, well, this is the second drawback of using the online version of the notes. You can insert a note, but it will disappear after you close the notebook session, right? Because this is running on someone else's server. So even if you save it, it doesn't really get saved, right? If you have your own version of the notes, so you have your own local version of the notes running, when you save this notebook, it'll save all of your exercise answers, and it'll save whatever edits you make to the notebook. Right. So this is the way that the notebooks are meant to be used, right? A lot of the students who are using the notebooks are just reading them. They might run the code cells, right? So when you see a code cell like this, they may actually run it, they may not. Right? A lot of them are just reading. A lot of students are just reading them and skimming them, but that's not the way the notebooks are meant to be used, right? They are meant to be used interactively. So you should be actively running any code cell, understanding what the output is, right? So you should be reading the output, trying to understand why the output is, trying to understand why the code cell generates the output it is. And then you really ought to go back and modify the code inside the code cell to make sure you understand what's happening, right? A lot of the notebook will actually suggest that you go back and edit a code cell to do something. Right, so for example, the reader should change degrees to a negative value and confirm that the output matches the expected result, right? And so on and so on and so forth. Now you've seen there's lots of exercises. So almost every notebook has some exercise in it. All of your answers are at the end. So there's a single notebook at the end of every major section of the notes that contains my answers to the notebook exercises, right? And they appear as a Jupyter notebook, so you can actually go in and edit a solution to see what happens, right? So you have access to all of the answers as well. What else do I want to do? Anything else here? You can see that there's a lot of notebooks, right? The plan is to actually get through every notebook. And again, oh, you notice here the course is broken down into 4 major parts, right? So part 1 is the basic language. Part 2 is where we actually start the object-oriented stuff. Part 3 is more advanced object-oriented stuff. Part 4 is yet more advanced object-oriented stuff and some data structure stuff. Right. So we actually cover quite a lot of material in this course. Let's see. So there will be a lecture on a lot of this material. Obviously, there's not a lecture for every notebook. So you are responsible for reading and understanding the notebook, the material in the notebooks. And I think that's all I want to show you. This is my own local version of the notebooks. So for example, if I click on a notebook here, so this is actually running on my computer. If I make a change to a notebook, for example, so for example, I add something here, I add something here, right? Run the cell. If I save this, close the notebook, and then reopen it. Oh, was it this one? Nope. Conditionals, right? Comparisons, Booleans. Which one did I just edit? Oh, here, Boolean operator. Here we go. You can see that it actually keeps it, right? So if you're the type of person or the type of student who thinks that they might want to modify their notebooks to make notes to themselves and so on and so forth, I I encourage you to try to install the software on your computer and run the notebooks on your computer locally. All right, what time is it? 10:11. Okay. So that's all I wanted to show you for today. Does anybody have any questions about today's lecture or about the course in general? You can unmute your microphone, put your hand up, type your question in chat, however you want. All right, so I should explain a few things. So the OnCue is not completely set up yet. So I'm late setting up the OnCue because of the fallout from last term. I ended up with 2 exams after the 20th in very large courses. Yeah, that'll be updated shortly, Teen Fing. So the OnCue is not completely up to date yet. I'm working on it now. I ended up with 2 exams after the 20th. So 21st and the 20th, I don't remember now. And there were over 100 exams that had to be marked. So I just finished marking the exams on Sunday. Sunday? Yeah, Sunday. So I am behind on getting stuff ready for this term. It's going to get worse because there are another 100 students who chose not to write the exam last term. They're going to have to get marked. So their exams are going to have to happen in the next couple of weeks. And I'm going to have to mark those as well. So it's going to be a couple of hectic weeks for me at the beginning of the term. So I'm asking you for a little bit of patience while I get everything set up. I'll try to get everything set up over the next couple of days. So you should be looking for updates on OnCue. You should see some pretty significant updates to OnCue over the next couple of days. In particular, where you can find links to the notebooks. Right, all that information will be posted on OnCue. All right, I'm not seeing any other questions, so I'm just going to end it there. I will try to post a recording of this lecture later this afternoon. And I will see you again on Thursday, right? Yeah, on Thursday.
Actually, could I ask a question real fast?
You can, of course.
So I haven't yet taken linear algebra, and
Yep.
it's a 2-semester course from what I understand, and it's also a prerequisite for a lot of future year courses. So I'm wondering how I'd go about fitting it in now.
Linear algebra?
Yep.
You're asking about the full term course? Because you won't be able to take the full year version of linear algebra right now. Because you have to start, that starts in September. So if you're trying to take the 1 year version of linear, or the 2-semester version of linear algebra, you'll have to take it in the summer.
Both semesters worth in 1 summer?
I believe so. I don't know off the top of my head. There probably is a 1-semester version of linear algebra as well. So for a lot of people are saying you can take Math 112, for example.
I'm curious if the 1-semester version is in-depth enough, though.
It'll be in-depth. It'll just be a lot harder because they're going to cover everything in one term. I don't know if it's harder. It'll just be coming at you faster. But like I said, you can always take it over the summer. I'm sure there'll be an offering over the summer.
Okay, yeah, that sounds good. Thanks.
Yeah. Okay. Upper years say it's very fast. Any other questions? All right, so if not, I will stop the recording there and see you on Thursday.